Okay, 3.4b homework, properties of exponential functions. Here's some practice, okay? So let's start with completing the table of values. Okay, so if we take all these x values and we actually plug it in right here to like where the x is in that equation, let's see what the y's are going to be. So we would have 3 times 4 to the exponent -1. I get 0.75. Okay, 3 times 4 to the exponent 0. I get 3. 3 times 4 to the exponent 1, I get 12, 48, 192. So 12, 48, 192, and then I get 768. Okay, so when we take a look at this, like what would be the first differences? We would go up here and we would subtract these. So 768 minus 192, I would get 573. And 192 minus 48, I'd get 144. 48 minus 12, I get 36. And then 12 minus 3, I get 9. And 3 minus 0.75, I get 2.25. Okay, so obviously the first differences are not the same. So we could try second differences, but then we can also try ratios to show that, I'm just adding this to the question right now. Okay, we can try ratios to show that this is an exponential function. Okay, so if we go up this column, we do 768 divided by 192, we get 4. 192 divided by 48, we get 4. 48 over 12, 12 over 3, and then 3 over 0.75. Okay, so we know that it's going to be exponential. So let's go ahead and go to the graph and let's graph this, okay? So -1 and then 0.75 and then 0, 3. The x-axis goes up by a scale of 1, and then the y-axis clearly goes up by a scale of 3. 112, 248. And then those are going to be off the graph, which is okay. Let's do that, okay? And we'll say this is f at x equals 3 bracket 4 to the x. Okay? So what are the values of a and b? Well, we can get that straight out of the equation. Okay, the a is that initial value, which is 3. B is the base, which is 4. Okay, this graph is increasing. Okay, I'm just going to circle that. Okay, the y-intercept, we can go to the table of values, 0, 3. Okay, now I'm going to add the asymptotes to this graph. Okay, our asymptote, because we didn't move up or down, our horizontal asymptote didn't change. Okay, we still have y equals 0. Okay, so there's a horizontal asymptote at y equals 0. Okay, and we could actually add that to the table of values as well. Okay, domain for exponential functions is always XER. Okay, that's not going to change unless it's in the unless it's like in any word problem. Okay, and the range is again going to depend on this horizontal asymptote. So we're always going to compare the y with the horizontal asymptote. In regards to, like, I call it the crocodile, okay, the inequality symbol, it depends on whether or not whether our graph is above the horizontal asymptote or below. So in this case, we're above the horizontal asymptote, so we have y is greater than or equal to 0. Okay, so complete the table of values and graph f at x equals 2 to the 1/4 to the x. Okay, so when we go ahead and we plot these numbers, so we're going to go 2 times, you can put 1/4 or 0.25 in your calculator, okay, to the -2. I get 32. Make my pen a little bit smaller. Okay, and then I get 8, 2, 8, positive 1, sorry, 0.5, 125. 0.5 is 1/2. This would be 1/8, and then this is probably going to be 1/32. Yeah, 1/32. Okay, so when we go ahead and do first differences, they're not going to be the same, but let's actually do the ratios. I think that makes more sense. Okay, so 1 over 32 divided by 1 over 8, we're going to get 0.25, so like 1/4. Okay, and if we go up this entire line, the entire y column, we're going to get 1/4. The other thing is we can just go ahead and say y equals 0 is the horizontal asymptote. Okay, so if we were to plot this, we get -2, 32, -1, 8, 0, 2, 1.5, and then it just gets smaller. Okay, so if we can see this, it gets closer and closer and closer to that horizontal asymptote, which is y equals 0. Okay, so the value of A is 2, and the value of B is 1/4. This graph is decreasing on the entire XCR, on the entire domain. Sorry, forgot to label the graph. Okay, the y-intercept, we can go to the chart or we can like look it up here. Okay, it's 0, 2. Equation of the asymptote is y equals 0. Okay, so then we have the domain. Domain is always XER. And I think I made a mistake in the last one, YER. Y is going to be compared to the asymptote, which is 0, and we're above the asymptote. Here's the thing, it doesn't have that underline there because it does not include the asymptote. Okay, number 3 wants us to match each equation to the corresponding graph. Okay, so I'm going to do this question in the order that I would do it, and I'm going to like go ahead and like think my way through it. Okay, so when I take a look at these 4, I think of, okay, so I'm just going to go through this. Base of 2 and base of 4, these are both increasing, okay? And base of 4 is also increasing. Okay, so that one's easy. In regards to base of 2, this one's going to be decreasing. So I'm going to find the decreasing one. So out of these, there's only one decreasing one that goes down like this. There's no reflections here. Like as soon as I saw number 4 here, I'm like, oh yeah, the reflections. Okay, so a little bit of a recall. But B is definitely going to match up to this graph right here. Okay, the other way that we can see this is like see how there's a y-intercept at 20. Okay, so y-intercept. So in order to find the y-intercept, just as a recall, we have to sub in x equals 0. So if we did that, that would go to 1 and then we'd have 20. Okay, so that works. All right, so that one's done. Now let's focus on the other 3. So of course, the base of 4 is going to be increasing or decreasing quicker, and then 2 not as quick. That may not be so self-explanatory, but I'm going to actually focus on this. This one is the only equation with the reflection, okay? So this would take our normal equation that goes up, okay, our normal graph, and it would reflect it in the x-axis, so it would look like it's going down. We only have one of these, which is number 4, okay? I'm going to be honest, like if we want to check the y-intercept, it's probably too close to 0 to even check, but we can check that the horizontal asymptote is still 0 and there's a reflection. So I'm pretty confident that that's D, okay? So D is done. Okay, not in any order whatsoever. I'm just picking out, like processes of elimination is key to these questions, because if you can pick out like key characteristics, you can go through them quicker, okay? So now we have a base of 2 and a base of 4, but then we have this, as long as we don't have a shift, like up by a number, here, this is going to be our y-intercept. So for example, y equals 22 to the 0, we're going to get 20, versus y equals 2 4 to the 0, we're going to get 2. So we can actually do A and C just based on y-intercepts. So we have a number here, it's very close to this horizontal asymptote versus 20. Okay, this is a very clear 20. So I'm going to say that this is A and then this is C. Okay, and lastly, number 4, determine the equation of the exponential in this form. So this form specifically tells us that there's a stretch. We want to know the base, and then it's to the x. Okay, so there's no shifts, and we're going to assume no reflections, okay, but there's no shift here or in the equation, or sorry, in the exponent. So what we can do is we can do like the ratios, okay? So if we do 128 divided by 32, or 32 divided by 8, or 8 divided by 2, or 2 divided by a half, we are going to get 4 every time. I'm going to tell you that means that our base is 4. So we're going to have 4 to the x. Now, in regards to our initial value, it's going to be this x, or sorry, this y-intercept. So I get 2. And that's it. Okay, so y equals 2, 4 to the x. Now, in the second equation, I'm actually going to like try to pinpoint numbers. So I get negative 2 comma 12. Okay, I get negative 1, 6, 0, 3, 1, let's call that 1.5. Okay, so without actually being able to pick out some of these digits, I may not even be able to give the base. Okay, because let's find the ratios and let's see what these are being multiplied by. Okay, so we go 1.5 divided by 3, I get a half. 3 over 6 is a half. And then 12 over 6 is a half. Sorry, 6 over 12. Okay, because again, we're going up that y-axis. Okay, so we're going to have y equals some number 1/2 to the x. Okay, this is our base. Now, our x or our y-intercept, I keep saying x-intercept, is 1.5. So we can put that right here. We can also, oh, I'm sorry, 3. I actually double checked right here, and then I realized that it was wrong. So good double check there. Y equals 3, 1/2 to the x.